Find the partial fractions, or the partial fraction decomposition for this rational function. Partial fractions means that two fractions were added together and this was the result. So what were the two fractions? Well, for the first step, what we need to do is factor the denominator. If that cannot be factored, partial fractions are not possible. So let's see, we've got x and x, we've got a positive and a negative. How about a 5 and a 3? So if you multiply that out, the middle term would be a positive 3x and a negative 5x is negative 2x. Okay, so it seems to have worked. So now what you do is take this 5x minus 1 over x plus 3 times x minus 5. And then you say that came from two fractions being added together. And the denominators are going to be x plus 3 and x minus 5. And then for the numerators, we don't know what they are, so we'll use variables. Usually capital A and capital B are used. And now the next thing to do is clear the fractions. So use the least common denominator, which is going to be this, and multiply both sides by it. So we'd multiply this side by x plus 3 and x minus 5, x plus 3 and x minus 5, x plus 3 and x minus 5. Alright, then start canceling. So x plus 3 and x minus 5 will cancel x plus 3 and x minus 5, leaving only the numerator, 5x minus 1. So that always happens on the left-hand side. Then on the right-hand side, x plus 3 will cancel x plus 3. So what's left is a times x minus 5. And I would suggest you don't multiply that out, just leave it factored like that, a times x minus 5. Over here, x minus 5s will cancel, leaving us b times x plus 3. Okay, now in order to find out what a and b are, you just plug in numbers for x. So what I could do is say, how about if I let x equal 5? The reason I chose that is because then this will be 5 minus 5 is 0, and it'll wipe out this term completely, making it a little bit simpler for me. So if x is a 5, this is going to be 25 minus 1, so that's 24, and then a times 0, and then b times 5 plus 3 is 8. So then we would have 8 times b is equal to 24. So there we have it in two short steps. Turns out that b is equal to 3. Alright, now how about if we let x equals, so this time I could say let x equal negative 3. So a negative 3, that would make this negative 15 minus 1 is negative 16. And let's see, if this is negative 3, then negative 3 and negative 5 makes negative 8. And then it's going to be b times 0. So you have negative 8a is equal to negative 16. So when you divide both sides by negative 8, then the negatives cancel. A turns out to be a positive 2. So that means that the partial fractions, or the partial fraction decomposition, is going to be a above x plus 3. So a was a 2 above x plus 3. And then b above x minus 5. So b was a positive 3 above x minus 5. Now this is used in calculus later on when you need to integrate something like this and you say, my goodness, that's too hard. Well, what you do is take this one that's more complicated and break it into two easy problems using partial fraction decomposition. And then it would be easy to use these two and integrate them within one step.